Good morning, dear students. Today we are going to discuss interpretation of the NMR spectroscopy. What is the topic? The topic is interpretation of NMR. This is the fifth unit. NMR. UV, IR already completed. Now NMR spectroscopy. NMR also almost, this is the ending topic of the NMR. If you know the interpretation, we can answer at least, we will get 5 marks easily. So no need to listen anything. Now listen this, today's class we will get the 5 marks very easily. Okay? It is an exam point of view, it is very easy and in the life also. That is like me, for example, medicines are there. All are in white color. You're removing tablet from the label sheet. Keep here. 3-4 tablets are there, but all are in white color. How can you identify? How it is possible? Or one more example. Sugar powder, carbohydrate powder, and glucose powder, fructose powder, all are in white color. Without testing, by looking with our eye, how can you know what type of compounds are there and what type of medicine it will be used and which tablet for which and which tablet for use, stomachache or headache or cancer disease or leg pain or heart attack. If all are white in color, there is no names. So this is how can you know? If you know the structure of the compound, that is very easy to identify the compound. Now, identification of organic compound, identification of medical compound, identification of food items. Whatever the compound in the nature, just depend upon the structure. The structure is able to identify the compound. So it is very easy. If you know the spectroscopy very well, we can identify, it's very easy. For example, 3 spectra are very important for the identification of the organic compound, all organic compound, all medical compound. The 3 spectroscopy are more important. What are that? More. What are that? That are mass spectroscopy. One is mass spectroscopy. The second one is the IR spectroscopy. Infrared. Already we have completed. This is in our syllabus. This is not our syllabus. Okay? IR spectroscopy. And third one is the NMR spectroscopy. If you know these spectroscopy, then the identification is very easy. Identify so the 3 white in color, so the 3 chalk pieces are white, but which one is used for the headache and which one used for the leg pain and which one is used for the cancer? So that is based on these spectra. This spectroscopy is able to identify the structure. Then structure we know, then that is very easy to identify. I will tell you, if you listen to today's class, then finally you can identify. It's very easy. Anyone can identify. Not only you, any intermediate student, graduate student, commerce student, MBA student, anybody can. Today's class, if you listen, no need to other knowledge. Just listen carefully. You can able to identify the organic compounds. Just listen, please. So mass spectroscopy. Mass means that is the molecular weight of the compound. A sample, if you give the sample to the mass analysis, that will give the molecular weight of the compound. For example, compound, this is the white color compound. These are the samples of the compound. This sample give the analysis. The molecular weight will come. Molecular weight. For example, CH4, it's a methane. Its molecular weight, carbon is 12 plus 4, 16. The mass. But the structure not able. Just mass peak will come in the spectroscopy. Mass mean molecular weight confirm. For example, oxygen, 8 plus 8, 16. It is also 16. But mass cannot give the structure complete. But it is only, its duty is what? To know the molecular weight. That's it. Molecular weight. Different types of molecules. But some of the compounds are same molecular weights. For example, one more. Propanol. Here, see that. 1, 2, 3 carbons. 1, 2, 3 carbons. 3 hydrogens, 3 hydrogens. 2, 2, 4, 5. 2, 2, and 3, 5. And 1 oxygen, 1 oxygen. Mean molecular weight same. Molecular weight also same. But the structure is different. The structure is different. Molecular weight how much? 12 into 3 carbons, 1 oxygen, 16, and hydrogens, 3, 2 to 4, 7, 7, 8 hydrogens. So total 12 plus 8, 20, and 60. So molecular weight of this compound is 60 and molecular weight of this compound also 60. But the structure is different. But this spectra gives only an idea about the molecular weight. This spectra gives only molecular weight but not structure. Okay. So molecular weight we have to know. That's okay. And now come to the IR spectroscopy. IR spectroscopy gives only functional identification. Functional groups. What are the functional groups? Halide is the functional group. OH is the functional group. Amide is the functional group. These are the functional. Alkyl is the functional group. Alkyne is the functional group. These are the functional groups. Higher infrared spectroscopy. IR mean infrared spectroscopy gives only that identify the functional group present in the compound. For example, here in propanol, and this is the one propanol, 1, 2, 3, one propanol, and this is the 1, 1, 2, 3, 2 propanol. 1 propanol and 2 propanol. In the 1 propanol containing the OH functional group and 2 propanol containing also OH groups, but it gives the functional groups but not correct structure. Only functional groups. So mass gives the molecular weight, IR gives the functional group. But exactly the functional group present where? In the first carbon atom. In this case, 1 propanol. But the functional group OH is present in where? In the second carbon. So this distinguish, this difference only NMR gives. That NMR, today topic is what? NMR interpretation. So NMR plays a very good role for the identification of all organic compounds. Okay, now NMR. Just we are giving the mass, molecular weight, IR, functional groups. But whereas in NMR spectroscopy. NMR means what? Nuclear magnetic resonance. In this, two types are there. Identification of the proton. Identification of proton and identification of carbon atom. Both carbon as well as proton. So two types of NMRs are there. Two types. What are that? Okay. NMR, there are two types. Four types are there. Phosphorus, fluorine, C13, proton NMR. But we don't want to that all these things. Only two types we have to know. In that only we have to study proton NMR. Okay. That is H-NMR, proton NMR and C13 NMR. Okay. This gives the what? Number of hydrogens. Number of hydrogens present in a organic compound. An organic compound or given sample. Or this one, the number of carbons present. Number of carbons present in a given sample. Okay. Now we are studying the only proton NMR. Okay, proton NMR. Proton NMR. The proton NMR mean identification of the number of hydrogens present in a given sample or in a given organic compound. Okay, that is important. You have to remember number of hydrogens. Okay, now so it's very easy to study. Only 3 steps are there. What are the 3 steps? The first step is the nature of the organic compound. Nature of the environment. Environment of organic compound. Okay. What type of compound is there? What is its nature? That is important. And second one is multiplicity of the compound. What is that? Multiplicity of the compound. Multiplicity of the compound mean based on the n+1 rule. n+1 rule, we have to know the multiplicity. Multiplicity mean what? Singlet, doublet, triplet, like that. That is the multiplicity. Okay. Now third one is the chemical shift. Chemical shift. Mean the chemical shift is the delta. We have to indicate the delta. The delta units are ppm. They are 0 to 12 or 10. 0 to 2. Okay. If we know these 3 steps, we can identify the any organic compound. We know the number of hydrogens present in the compound. Already we know the mass, functional group, now hydrogens. If hydrogens are known, we can know that the presence of functional group. Okay, we will identify the 2-3 compounds last. After completion of this, how can you identify the organic compound? We are taking the 2-3 examples. Okay, first we study the what nature of the environment. Okay. Nature of the environment of the compounds. We will discuss more than 5 compounds as examples. So first example is the methane. So what is its nature? The hydrogens. We are targeting what? NMR. In NMR, proton NMR, hydrogens, identification of the hydrogens. Okay. So that is what is the nature of the hydrogens present in this compound. So here nature means the 4 hydrogens are equivalent distant to the carbon atom, mean all are in the same. So single environment is there here. Single environment mean only one peak will come. How many peaks? Only one peak. One peak. One peak. In a graph, only one peak. If we take the another example, CH2. CH2 means we can write like this: hydrogen, okay, 2 hydrogen. So here also the 4 hydrogens are also, what is the nature? Same or different? Here also same nature. How? So one carbon, same distance is there, carbon. Hydrogen, 2 hydrogens are same, attached with the double bond. Here also 2 hydrogens attached with the carbon and attached with the double bond. Same. See, hydrogen, carbon, double bond. Hydrogen, carbon, double bond. Same nature. So only one peak will come. Only one peak. Okay? Now, if you take the benzene ring, hydrogen. How many peaks will come? Here the nature, the carbon attached with one hydrogen. Only one peak will come. Acetone. Here how many peaks will come? CH3, C double bond. CH3, C double bond. Here also only one. So first we decided how many peaks will come in different organic compounds in a given spectra. Even given spectra, after taking the spectra. So look, here one peak, here also one. This compound gives the only one peak. This compound gives one peak. This compound also one peak, and this compound also one peak. That is called what? Nature of the environment. Okay, one peak will come. So one more example. Here, if this compound is there, propanol. What is this nature? What is this nature? Here, CH3, equivalent distance the CH compound, and here CH3. So this is the one nature, A compound. Environment. These 2 methyl groups gives one peak. Okay? And here CH, only one CH. This is attached to this methyl group, and at the both sides the methyl groups are there. So here the B mean one more peak. And here OH. This is also different environment. Only OH is there. Hydrogen attached with the oxygen. Here one hydrogen attached to one carbon. So only one hydrogen is there. So one peak. And here mean how many? C. A, B, C. Mean 3 peaks will come. This type of compounds mean 2-propanol gives 3 peaks. Mean these are 1 peak and this is the 3 peaks. This compound is showing 3 peaks. So nature, this is the environment of this compound. Here then three types of environment are there. One, methyl group, CH and OH. Okay, clear now? This is the environment, identification of the environment. Now, one more example. If CH3, CH2O, CH2, CH3. If this compound is there, environment. What is the environment? CH2 attached with the oxygen atom. This shows the one peak, mean one environment. And CH3 attached with the CH3 attached with the CH2. And this is B. So here 1 plus 1, 2 peaks will come in this. Here 3 peaks, here 2 peaks, here 1 peak. This is the environment of the compound. We have to know the environment in any given organic compound. Whatever you study in intermediate, take the organic compound to study the peaks, number of peaks. Okay, so number of peaks we know. Now, the second one is the multiplicity. Multiplicity or n plus 1 rule. Multiplicity means either singlet or doublet. What are the compound given environment? 2 peaks. That 1 peak is either singlet or doublet or triplet. And in the given 3 protons are there, singlet or doublet. That is called the multiplicity. So multiplicity means according to n plus 1 rule. So what is meant by n? The n is equal to the number of protons. Protons mean H hydrogen ions. Number of protons present in the neighboring compound. The neighboring carbon atom. Neighboring group, you can say neighboring group. Okay. Here we are taking one example. CH, Cl, CH2, Cl and Cl and Cl. This is the organic compound. What is it? Trichloroethane. We can say trichloroethane. So 1, 2, 2. What is the I base name? 1, 2, 1, 2, 1, comma. Otherwise, we can say 1, 2. So 1, 2, 2 trichloroethane. This is a compound name. Here, according to environment, what type of environment is there? Here, how many peaks will come? See, here, this hydrogen attached with the carbon as well as 2 chlorine atoms. And here, only one. These 2 hydrogens attached with the carbon and 1 chlorine atom. This is the peak. Mean 2 peaks will come. 2 peaks will come. 2 peaks according to environment. Already we studied just before. Now, multiplicity. So this B is the neighbor of A. A is the neighbor of B. Neighboring group. B is the neighboring group of A. A is the neighboring group of B. So here, if we have to count the B equal to what is the number of? Neighbor is which one? So only how many protons are there here? Only 1 proton. So n is equal to 1. N is equal to 1. So according to n plus 1 rule mean, so 1 plus 1, so here doublet will come. So here this is the B, this is the C. So doublet when this peak will appear like a doublet. So this peak appear like a doublet. This is called the multiplicity. So neighboring group appeared. This B group is appeared because n is equal to what? So doublet group, because the H is n is equal to 1 plus 1 2, so doublet. So now A neighboring group is the B. A neighboring. So how many hydrogens are there? 2 hydrogens are there. That n is equal to 2 plus 1, 3. So here A is the triplet. This is the triplet. So here the ratio 1:1 peaks. Here the 1:2:1. See, double the distance. 1:2:1. So this is called the multiplicity. If you know that spectra containing like this one, so here, so B is the one, doublet will come, and A is the triplet will come. So first environment, then multiplicity. Okay, multiplicity. This is the best example. Okay. Now, last one is the chemical shift. If you want, I will give one more example. Okay. We'll look the one best example. CH3 this one. Okay, here see, environment, here the environment is the A and A. So B, this is the mean 2 peaks will come. 2 peaks will come. Okay, 2 peaks will come. What is the multiplicity? A is the neighboring group of 1. So mean A is equal to n plus 1 rule. Mean 1 plus 1 is equal to doublet. So doublet. Doublet. Okay, one is the A is equal to doublet. And B is equal to what neighboring groups are? How many is there? Here 3 is there, here 3. 6 plus 1. So 7. So 7 will come. 1:2, 2:3. So small multiplicity will come. Like this. 1, 2, 3, 6, 7. Like this will come. In a graph, this is the. So 7. One is the doublet and this is the multiplet in sextet. So this is one more example. So multiplicity. But here the last topic is the chemical shift. Chemical shift mean delta value in a group, that is, for example, it is there. Here it is a downfield in de-shielded and upfield shielded. Already we studied in chemical shift what is meant by shielding, de-shielding. Shielding and de-shielding is called the chemical shift. Okay, so this is the downfield and upfield. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, We'll do again. Little bit. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is this number? These are the delta values. What is that? Delta values. So the water units ppm. ppm means parts per million. So here 1, 2, 3 up to 12 the delta value of the all organic compounds. We know the nature of environment and multiplicity. And that peaks are appeared in where? What type of compounds appeared in the graph position? This is the position of the graph. So graph is like this. So this is the position. Here at 0 degree, the reference compound is there. We know that reference compound. What is the reference compound? Tetramethyl silane. What is that? Tetramethyl silane. Only one peak will, because the environment is same. Only one peak will come. One peak. One peak. Like this. At what position? What is the ppm value? 0. It is a reference compound in all organic compounds. And 0 to 1, all alkanes. All alkanes. Example, CH4, CTH6, methane, ethane, propane, butane, hexane, cyclohexane, petroleum products. All are appeared where? 0 to 1. 0 to 1 peaks. Like this. Here. Like this. All alkanes will come. And 2 to 4, that will come the aryl methyl, mean this compound. Aryl mean aromatic CH3 or aromatic CH2. Like this. This type of protons are appeared here. 2 to 4. And 4 to 5, allyl groups. Allyl compound means double bond CH, C double bond CH. This type of protons are 4 to 5. And 6 to 8, here all aromatic compounds. So that is benzene, proton, this proton, and this proton, all protons of all aromatic compounds. Pyridine, okay, pyridine or purol, purone, all organic compounds will come. And 9 to 10, that is aldehyde groups, CHO groups are present. And 11 to 12, acid groups. This is main important. In a given organic sample, first mass gives the molecular weight, and next IR gives the functional group, and NMR gives the number of hydrogens and number of carbon. And where it appeared in a chemical shift to that which group is appeared in which position. Okay, so now actual questions they will ask in the university. So that one compound we have to analyze, 1 or 2 compounds. There is no time now, so only we will analyze the 2 compounds, at least 2. If time permit, we will explain that also. So now see the example, CH3, CH4. What question? Predict the NMR. Predict the NMR of this compound. So predict this one. So how can you predict this one? What is the nature? Here, see nature, CH3 group and CH. And mass we have to know. First you take the mass. Molecular weight is the 12, 24, 4, 28 plus 16. How much? 8, 6 means 14 and 1, 44. Molecular weight. And also take the IR. IR gives the halide function. That is present in where? 1721 centimeters. So functional group, you know, CH group is there in the graph and molecular weight. And in NMR, first see the nature of environment. What is the nature? Here, this hydrogen is attached with oxygen and carbon. So mean A. And here CH3 mean B. So two types of peaks will come in the nature. And what is the multiplicity? Multiplicity. We see here the neighboring compound of this one here. So B equal to neighboring compound, n plus 1 rule mean one doublet will come. So doublet. Mean 1 plus 1 mean here n is equal to 1. So n plus 1 is equal to 1 plus 1 mean 2. So doublet will come. 2 mean doublet. And A. So A is equal to what? Here 3. So 3 plus 1 mean quartet. Quartet mean multiple compound. So 1 is a multiple mean 4. Quartet. We can say quartet. This is doublet. So one peak is a doublet, another peak is the quartet in a spectra. So look the spectra here. Nature of the environment, 2 peaks, and multiplicity, one is the doublet, another one is quartet. And now come to the chemical shift. So here the CHO is there. CHO is appeared where? 9 to 12. So 9 to 12. So 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 to 10 and 11 like that. So 9 to here what type of peak? Peak will come? Quartet peak. Quartet. So this type of peak here appears. And this one A. That's the quartet. And methyl. So methyl means alkanes. Alkanes are present in where? So 0 to 2. This is the what? TMS. Reference compound. Tetramethylsilane. And 0 to mean at this side here appear the compound. But doublet. Like this. So here the quartet and doublet. So we know this compound is completely, mass will know, IR will know, and this is the prediction. So CH3 will come. If we take the C13 NMR, the number of carbons also there. Number of carbons 1 and 2. 2 peaks will come. So this is about the prediction of NMR. Okay, and one more example. This is important. So 2 propanol and this is the 1 propanol. 1 propanol. So molecular weight is the 60. Functional group is the same OH. Both the molecules. And environment. So environment here 1, A, here also A. So B and C. And this one also 3 peaks. Here 3 mean 1, 2, 3 mean 3 peaks will come. And multiplicity. So multiplicity mean A is equal to what? Only doublet will come. CH. And OH is presented to 5 to 4. 5 to 1. Here the OH or NH. OH or NH. Here at pi position OH or NH. And this methyl group is at 2 position. How many doublet will come? Doublet will come. And B compound, it is attached with oxygen. Negative compound mean, so that negative compounds are always in comes at 5. All halogen compounds or oxygen attached with the negative compounds will appear here 4 to 5. So here the multiplet, because 6, 3 plus 3 and at pi position your multiplet will come. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the propanol will come. This one. And whereas here also, here, so here CH2, CH3 is there. here CH2, only not CH group. So here this one is the multiplet because the 2, 3, 5 plus 1 multiplet, and this one is the triplet will come. Here this A, B, C. Here 2 plus 1 triplet. 2 plus 1. N plus 1 is equal to, here neighboring protons how many? 2. 2 plus 1 is equal to triplet will come. This A is equal to triplet and B is equal to multiplet. And this is called also triplet. Means 2 triplets and 1 singlet and 1 multiplet. According to that, we have to identify the all organic compounds. Any organic compounds. Okay? Thank you very much.